Welcome everybody, my name is Thiago. I'm very proud with the opportunity to show you this study. The study is about learning curve as a parameter for estimating costs in industry. The authors are José Ângelo, João Vitor, and I, Thiago. We have developed this study at the Federal University of Technology, Paraná, Brazil. The abstract shows us that Brazilian furniture companies are operating in a competitive environment, and the organizations must look for alternatives to appropriate and control the manufacturing costs of these products. The objective of this study is to compare the different costs through learning curve and chrono analysis calculations, and so we can reduce the production costs and increase the company's competitiveness. This study will discuss the application of the learning curve to appropriate the labor cost of new items manufactured in the factory. And for the data analysis and discussion, Wright's learning curve model was applied in the calculation of the time cycle length required to meet the production lot, and after we can calculate the unit labor cost, and we will compare with the chronoanalysis method. This industry manufactures dining room sets, and it was committed to deliver the first batch of 168,000 units within 6 months, totaling 138 days work. The work center assembles chair seats and holds 5 operators. The production planning sector used 33,600 units as average unit standard time to assemble chair seats and meet the lot, and had programmed these units for each operator. The same average time of 2.83 minutes per unit was used to calculate the item's labor cost. The data was collected by the chronoanalysis technique, and the information at the form was the operator's name, quantity of parts produced a day, and the unit manufacturing time. With these information, we could get the operator's learning and after the costs. This figure shows us the learning curve of all operators. We could get the learning curve with the times, so T1 is the time to produce the first part, and T2 is the time to produce the second part. We can see it in the equation 1, and so on. Thus, the more time collected, the more accurate the result will be. After we have found the learning curve for all operators, we can get the slope, which is the natural logarithm of percentage of the learning curve divided by the natural logarithm of 2, and the r squared can be found in the graph of the time curve. With the time of the first piece, the number of the last piece produced, and the slope, we can find the time of the last piece on the learning curve, while the chronoanalysis was done only the average of all times, indicating that all times from the first to the last piece are the same. We can also verify the time difference in days in relation to the amount of days to complete the total batch of pieces, comparing the calculations of learning curve and the chronoanalysis. It is also noted that the operators with the learning curve farther from 100%, operators 1 and 5, are the ones that show the biggest time difference. In a 108-day production, the difference in calculations also shows that the operators with the greatest potential for learning gain are the ones that show the greatest difference between the unit produced. This disparity between the calculations is also shown in the average time for production of 1 unit of the batch. The table 6, the costs per unit per piece by chronoanalysis method, use the same cycle time for all operators, and consequently, the cost will be the same for all of them. Differently, the learning curve method will give us a specific time average for each operator. So, with this data, we can define which operator will bring the lowest cost to the company. This operator will be the operator 5. The table 8 will show us why the learning curve should be implemented. For example, the operator 2 has the second largest learning curve. That is, it does not have a large space for learning, and also, when producing the first part, it was the second that had the longest time. So, the average of all operators, or the chronoanalysis, showed a lower cost than the real cost of this operator per part. This figure shows the total costs of each operator in relation to the calculation of the chronoanalysis with the learning curve. And this table are the values of the calculations that were shown in the previous graph. It's noted in this figure the cost difference from the first piece and the last piece. It's possible to observe the operator 2 in red, that because its learning curve is close to 9%, very close to 100%, there is no significant reduction in time between the first part produced and the time of the last part, as observed, for example, in operators 1 and the operator 5. This study showed us the importance of considering the learning effect to determine of unit and total cost of labor through the manufacturing process, thus enabling the definition of new strategies as to reduce production costs and increase the company's competitiveness in such environments. Thank you.